In this lab, we will continue with the data visualization. We will show distribution in the data using histogram and kernel density function. Histogram is the most popular way to show the distributions in the data. Let's try histogram with our New Zealand cars data. Let df cars equal pd dot read underscore cv of the file name, and let's look at the first few lines of this data frame. So df cars dot head open and close bracket will give the first 5 lines. So the columns are object ID, basic color, body type, CC rating, first New Zealand registration year, first New Zealand registration month, gross vehicle mass, import status, industry class, make, and so on. Now we want this object ID to be the index. So at the moment the index ID is from 0, 1, 2 and so on for the number of rows, and we want to allocate index ID to be the index, object ID to be the index. So let df cars equal pd dot read underscore cv of the name of the file, New Zealand cars.csv, comma, index underscore call equal object ID. So printing df cars, we can see that now the object ID is the index of the data frame. Then we look at if any of the values in this data frame is not applicable. So to do that, we will put the name of the data frame, and we will subset the data which is the data rows which is not applicable in the rows. So the way to do it is to pass the command df cars square bracket df cars dot is na open and close bracket dot any, and then inside the bracket we will put x is equal 1. Putting x is equal 1, it goes to the columns, or columns, yeah, each of the columns, and then close the square bracket. And so we can see that there are 636 rows which is not applicable. So let's have a look. So in these rows, so for example, we have not applicable here, and we have none here, and we have not known here, and we have unknown here. So, so these are the NA values. Now we want the DF. We want to fill all the NAs with 0. So let df cars equal df cars dot fill NA with 0. So let's check which after filling the missing values with 0, we now look at if there is any missing values in the data frame. So we pass the command df cars square bracket df cars dot is na open and close bracket dot any, and in the bracket we will put x is equal 1. So we have 0 rows. Now checking the first few lines of df cars dot head open and close bracket, that gives this, and we can see that the yeah, so if we do head, so we want to fill all the NAs with missing values with 0, and then we will check the first few lines. So checking the first few lines, we see unknown, not known, 0, and we see none, 0. So all the name values, has been replaced with 0. So we still have unknown and not known written, and they are the missing values as well. So we can, if we want, then we can fill those missing values with 0 as well. So now let's go to the next step. Let's find out the distribution of CC rating among the cars imported to New Zealand. So we know that cars imported to New Zealand. So to find the cars imported to New Zealand, we see which row. So we see that TLA is Auckland, and that's New Zealand. And so CC rating. So we have CC rating here, 1971, 1769, and so on. So let's do the plotting. Let's look at on the distribution on the histogram. So PLT.hist of DF cars gross vehicle mass, comma, bins equal 100. So PLT, so we want CC rating. Yeah, so we have plotted CC rating over here. So first we have got gross vehicle mass. So PLT.x label equal vehicle mass, and PLT.y label equals number of vehicles. So bins equal 100 will give us 100 bars. So this is how it looks like. So we can see that for vehicle mass equals 0, there is a lot of vehicles with the vehicle mass 0, which means that the gross vehicle mass value is not entered for the many number of vehicles. And then we see a nice binomial kind of shape of the graph, a bell shape. So and then let's do the histogram plotting of the CC rating. PLT.hist of open bracket DF cars and of CC rating, PLT.x label CC rating, and PLT.y label number of cars. So we see this. So there is some cars with 0 CC rating, and most of the cars are with CC rating from approximately 1700 to 2200. It's hard to see with such large bars. Let's find a beta value for bins, which is the number of exact intervals where the data is counted. So if I do bins equal 100 for CC rating, then we get this. So we see that the highest number of cars with the CC rating is around 2000. Okay, so now let's have a look at PLT.hist of DF cars CC rating, comma, bins equal 50. So the interval is a bit thicker, so that's why the bars are a bit thicker, and there are 50 bars. Now we will get some, when we do sns.histplot, we will get some warning messages. So to avoid seeing those warning messages, we will import warnings, and we will do pass the command warnings.simpleFilter. Inside the bracket we will have ignore. Then we import seaborn as sns. Then we make a default density plot of CC rating. So sns.histplot of DF cars CC rating, and we want to see the kernel density the estimate, and we say KDE equal true. So we look at the histogram. This is the bars, they represent the histogram, and this curve is the KDE, the density estimate. With this histogram chart, it is also interesting to see if we can show the density function of the data instead of bars. This can be done using kernel density function plot from the seaborn. So we don't have to import the library again because we have already done that. So we will pass the command sns. So sns.kde plot of DF cars of CC rating, and we get this. So we can see that as the CC rating increases, there is highest density around the value of 2000, and then it starts decreasing. So it looks like right skewed as well. Next, we plot gross vehicle mass using kernel density function plot from seaborn. Add customized labels of x and y axis instead of having seaborn to set them automatically. Seaborn also allows us to easily plot box plot, which shows the median, percentiles 25th and 75, and as well as the outliers in our data sets. Let's look at the CC rating of these vehicles versus their types. Let AX equal sns.boxplot of x equal df cars, bracket, we will have body type, comma, y equal df cars, bracket, gross vehicle mass. So on the x-axis it will have the body type, and on the y-axis it will have, the graph will plot gross vehicle mass, and it's a box plot. So this is how it looks like. We can see the labels on the x-axis are overlapping, and we also see that, yeah, so we can see all this, but we can't easily see what is written in the x label. So the x label are all on top of each other. Let's try to rotate them. So let's check what are the body types. DF cars, bracket, body type dot unique, open and close bracket. This gives the list of the body types. And the saloon, hatchback, station wagon, motorcycle, light van, flat deck trailer, boat trailer, domestic trailer, utility, tractor, other truck, self-propelled, caravan, sports car, flat deck truck, heavy rain, service coach, caravan, other commercial trailer, convertible, minibus, mobile phone. Let Ix equal sns.boxplot of x equal df cars of body type, comma, y equal df cars of gross vehicle mass, and then we want to rotate the x labels, so x tick labels. So we'll do ax dot set underscore x tick labels bracket ix dot get underscore x tick labels open and close bracket, comma, rotation equals 70, comma, hi equal right. So it gives this. Now we can see that the x tick labels are clear now. So now we can read. So this purple one, it is for commercial trailer, other commercial trailer, and we can see the upper tail goes above all the upper tails, so it has the maximum value there, maximum gross vehicle mass. And we also see that the median is bit lower. So the median for we see the median for service coach is higher. We can't see the horizontal line, so it doesn't have a median. So but we can see that other truck has the next highest median. So let's have a look. As we can see, in terms of gross vehicle mass, the other trucks, so other commercial trailers, so this is other trucks and other commercial trailers, which is this one, have huge range of variation. So we can see the median for other truck is much higher than other commercial trailer median, and the gross vehicle mass for upper tail for other truck is lower than for other commercial trailer, and where the mass can get very high. The mass can get very high. Yes, so we have gross vehicle mass for other trailer and other truck is quite high. On average, service coaches are the largest of all. So on average, service coaches, which is this, it has the highest median. Next, we show a box plot of vehicle type versus CC rating. Make sure that you rotate the x-axis labels so they are not on top of each other. So let Ix equal SNS dot box plot of x equal DF cars of vehicle type, comma, y equal DF cars of CC rating. So we have x-axis representing vehicle type, but we can see that the x-tick labels are overlapping on each other, so it's very hard to read the graph. So let's rotate the x-tick labels so that we can read the labels better. So let Ix equal SNS dot a box plot of x equal DF cars of vehicle type, comma, y equal DF cars of CC rating, Ix dot set underscore x tick labels of bracket, Ix dot get underscore x tick labels open and close bracket, comma, rotation equal 40, hi equal right. So that gives the clear x-tick labels. So we can see that the maximum CC rating is for bus, and the lowest CC rating seems to be for trailer or caravan and mobbed. Okay, so the highest median CC rating seems to be for this tractor. The violin plot in Seaborn is quite similar to box plot because it also shows distribution, but in a more detailed way. Try the SNS.violin plot on few pairs of variables in the dataset. Which one do you find most interesting? With that, another way to visualize the same information is to use Valin plots, which instead shows the density distribution of each vehicle type. So let Ix equal SNS dot Valin plot of X equal DF cars of vehicle type and Y equal power rating. So we want okay, so we can see the X tick labels are overlapping on each other, so it's hard to read which one is which. So let's rotate the X tick labels. So by passing the command ax dot set underscore X tick labels of ax dot get underscore X tick labels open and close bracket, comma rotation equal 40, comma HA equal right. So we get this. So the lowest value, the power rating is for motorcycle, and then we see the highest power rating is for motorcycle as well. Okay, what else can we see here? So we see that the median for motorcycle is higher than others, and for trailer caravan, tractor, mobbed mobile machine, the power rating is almost 0.